Today we are going to analyze the machining chapter in Decoding Gate Mechanical book. Machining chapter is introduced by giving a small definition followed by some examples of traditional machining processes. Under machining, first topic is mechanical transmission system, which is explained with help of a diagram. In first para, it is explained how the mechanical transmission system helps in transmitting the power obtained from prime mover to other work holding devices. Second para explains the need of transmission system to provide a wide range of speeds depending on the combination of tools and work metal used. And coming to the third para, it explains the working of mechanical transmission system and important parts which helps in achieving the desired speed. Important points are highlighted by a small symbol as shown here. An expression for calculating the spindle speed is also provided here. Important relations are given in a box for quick revision. Here the relationship between the spindle speed, velocity and diameter of the workpiece is given. In next page, the expression for speed range ratio is evaluated, which is the ratio of maximum and minimum spindle speeds, and after each formula the abbreviation of the variables used in that formula is given separately for a quick clarification. The expression for progression ratio is given with few points explaining why the geometric progression is used instead of other progressions. Below this, there is an example problem explaining the calculation of intermediate spindle speed with important points which are highlighted as note. The next topic is turning operation. There are three types of turning process, under which the first one is plane turning. Here a small basic definition of plane turning is given, followed by expression of machining time. In plane turning operation, based on the number of cuts, the total time can be calculated for two different conditions. Total time for the first case is calculated when the number of cuts is less than or equal to 5. Similarly, total time for the second case is calculated considering number of cuts greater than 5. Next topic is phase turning operation. It is defined and explained with help of a diagram, followed by an expression for constant speed and constant cutting velocity in detail. Next we have taper turning operation. It is defined and explained how it is performed in series of steps depending on the required taper angle. In next page, the total time for taper turning is explained in detail using inclined length, which is obtained from the above figures. While explaining the expression for total time, I have given small bulletin or notes in a semi-closed box for a better understanding. Next topic is taper turning methods. There are 4 methods by which taper turning operations can be performed. Here only important crisp points are given, and in tailstock offset method, formula for calculating the offset length is drawn out with help of a diagram. Next topic is thread cutting operation, which is defined and explained with help of a diagram, and at bottom of that page have given the types of questions that can be asked in the exam. Type 1 consists of questions based on machining time, and type 2 questions are based on gear ratio, which provides the relationship among pitch, speed and number of teeth. Next topic is drilling operation. It is defined with help of a diagram, below which the formula for calculating the machining time is given. In drilling operation, the machining time can be calculated based on the given data, which is explained as method 1 and 2. Below the method 2, the formula for feed and material removal rate is given as note. Next topic is shaping and planning operation. Here a small introduction is given, and in next page 2 main mechanisms used in shaping operation are provided. It is followed by a formula for machining time. Next operation is milling. Milling process is defined with help of a diagram, and formula for machining time is also given below. In next page, difference between the symmetrical and asymmetrical milling process is explained with help of a diagram. Next topic is indexing operation. A small definition is given at the top, followed by types of indexing operation with formula for crank rotation. Our next topic is grinding operation. A small definition is given at top, followed by the formula for machining time. In surface grinding, I have made a small mistake. In the expression for volume of wheel wear, squares should be neglected. So the final formula is just Ti minus Tf. And the final operation is broaching. A small definition is given, followed by a formula for machining time in the next page. Problems have more weightage in the production subject. Hence, for solving them more effectively, I have given the important formulas separately so that we can have a quick revision of these formulas before solving the problems. To gain a better understanding of the subject, solve as many number of problems as you can. I have provided previous year GATE solutions with a detailed explanation, and solutions to each problem comes with formula used and necessary diagrams. First, try to solve the problems by yourself without seeing the solution. Let us see few problems. In problem number 1, a 6-speed gearbox has to be designed for center lathe for turning mild steel and cast iron rods of diameter ranging from 100 and 200 mm. So here the maximum diameter is 200 mm and minimum diameter is 100 mm, and maximum and minimum cutting velocities are given as 120 and 40 meter per minute. The formula used for this problem is given separately. The first formula is speed range ratio, that is the ratio of maximum and minimum spindle speeds, and second formula is progression ratio. From the given data, we can easily find n minimum and n maximum values from maximum and minimum velocity. But to calculate the intermediate spindle speeds, we have to calculate the progression ratio value, that is small r. The expression for geometric progression ratio is given here. To calculate it, first you have to find the ratio of n maximum and n minimum, which is given as ratio of V maximum by D minimum into D maximum by V minimum. Substituting the values of velocity and diameter, finally we get n maximum by n minimum as 6. Substitute in progression ratio formula, we get R value as 1.43. N minimum or N1 value can be easily found out from spindle speed formula by substituting the values of V minimum and D maximum. Finally, we get N1 value as 63.66 rpm. Same way, we can easily calculate the N maximum value also. Coming to intermediate spindle speed value, for calculating the second spindle speed, we are substituting N maximum as N2 and N minimum as N1 in the progressive ratio formula. We know the values of R, N and small n. Since we are considering only two spindle speeds, small n value is taken as 2. Similarly, for the third spindle speed, small n value is taken as 3. So by just substituting in the formula, we can get the values of other spindle speeds also. Let us solve the problem number 4. Here in the question, they have clearly mentioned that diameter of MS bar has to be reduced from 80 to 60 mm. Since the diameter is reduced, it is a plane turning operation. And other given data are length of the workpiece, feed, depth of the cut, velocity, approach and over travel values. And they have also mentioned the time for return and resetting the tool between the passes as 10 and 30 seconds. They have asked us to find the spindle speed and total machining time. In plane turning operation, depending upon the number of cuts, the total machining time also varies. So first we have to find the number of cuts by substituting the DI, DF and the depth of the cut. Finally we get the number of cuts as 4. Since number of cuts is less than or equal to 5, we can find the total time by adding machining time for individual passes. So the total machining time is T1 plus T2 plus T3 plus T4. The machining time for the first pass is L by F N1. Since diameter is reduced for every cut, spindle speed also varies accordingly. Spindle speed for the first cut is 1000 V by pi Di. Substituting the velocity and diameter, we get N1 value as 525.21 rpm. Similarly, we can find the spindle speed for successive cuts. Here, diameter after the first cut is d1, which is equivalent to initial diameter minus twice into depth of the cut. After calculating all the spindle speed value, we can find the total machining time. Substitute the length, feed and spindle speed value, we get total machining time as 4.14 minutes. Here the key point is the time for return and resetting between the passes is given, and we have already calculated the number of passes as 4. Hence the return and resetting is done 3 times. So we are multiplying 3 to sum of return and resetting time. Finally we get 120 seconds, which is equal to 2 minutes. So the total machining time is 4.14 plus 2, 6.14 minutes. Let us solve the 12th problem. It is a drilling operation where diameter of drill bit, approach, over travel, thickness of workpiece are given. They have asked us to find the drilling time. Formula for drilling time is L by Fn, where this capital L refers to the total length of the tool travel, which includes depth of the workpiece, approach, over travel and compulsory approach, that is AP1. Compulsory approach can be calculated using the formula AP1 is equal to d by 2 cot beta, where d is diameter of drill bit, beta is point angle, which is a constant value of 60 degrees. Substituting the values of diameter of drill bit and point angle in compulsory approach formula, we get AP1 value as 9.20 mm. To calculate the total length of the tool travel, substitute the values of approach, compulsory approach, over travel and thickness of the workpiece. After calculating L and spindle speed, we can easily find the drilling time, which we are getting as 2.03 minutes. But the calculated drilling time value is not given in the option. Hence, let us calculate the drilling time without considering the compulsory approach value, which is given here. Finally, we get T value as 1 minute 53 seconds, which is correctly matching with the option D given in the question. Let us go to the next section in the machining chapter. This section mostly helps us to solve the theory questions, hence it is named as points to remember. Under this first topic is machine tool construction. We discuss about important points in the construction of lathe bed. Coming to turning operation, here points are just repeated from the previous sections, and example problems are also given, which you can solve by yourself. Next topic is thread cutting. Here I have given points on thread cutting operation and types of threads, followed by an example problem. Then in next page we have different types of drilling and boring operations, followed by milling operation. I have given the difference between up milling and down milling operations. Next we have grinding operation. Initially the specifications of the grinding wheel is given, followed by a detailed explanation of each specifications. First we have types of abrasives. Here the important characteristics of each abrasives are given in points. The next specification is grain size. Here I have explained the relationship between grain size and grain size number, followed by a calculation for cuboidal and circular grain size for a given grain size number. Next topic is grade, which is used to define the relative hardness of the grinding wheel. The coding for grade of the grinding wheel is given in a tabular column. In next page there is explanation on why different grades of grinding wheel is selected based on hardness of the workpiece. Next specification is structure, which is explained in detail in next page with help of a diagram. Here structure code and types of structure is provided in a tabular column, followed by an explanation on why different structure is used based on hardness of the workpiece. In next page there is a detailed explanation on selection of structure based on the required surface finish. And the last specification is bond. Here the types of bonds along with their characteristic features are explained in points. In next page a detailed summary of important values and points on Each characteristics of the grinding wheel is provided. It is followed by example problems to get a better understanding of the topics. In next page, important points in grinding operations are given, and it concludes our first chapter. The beauty of this book is its contents are presented in a precise manner without leaving any major topics. Thank you.